Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the real-world applications of trigonometry. Today, we are going to learn more about angles of elevation and depression and how to use them to solve real-life problems. By the time we have finished today's lesson, you will have a very good idea how you can apply trigonometry to find out more about the world around you. Let us observe the flagpole on the top of this house. We can see that it is very tall, but it does not extend to the ground. We will use a new method of problem solving to discover its length. The observer is standing 30 meters away from the house. When his line of sight is directed at the bottom of the flagpole, its angle of elevation is 40 degrees. When he is looking at the top of the flagpole, its angle of elevation is 45 degrees. The tangent of 45 degrees is equal to 1. So when we multiply that by 30, we are left with 30. The tangent of 45 degrees is equal to 0.839. When we multiply that by 30, the product is 25.17. Then we subtract 25.17 from 30. The result is 4.83 meters, the length of the flagpole. It is now time for an activity. Please look at the following picture. Use the angle of depression to calculate how far apart the boats are. Good luck.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Let us solve this problem together. We must remember that we are using the angle of depression, not elevation. We must subtract the angle of depression from 90 degrees. Then, we must use the difference in our calculations. A tangent of 50 degrees times 200 is 238.35. A tangent of 45 degrees times 200 is, of course, 200. When you subtract the lesser distance from the greater, you will see that the boats are about 38.4 meters apart. If you did not get that answer, please ask your teacher after the lesson. If you did get that answer, great job! We are getting toward the end of this unit, students. We must be sure that you have mastered right angle triangles. I will now give you 2 different questions to answer. Listen closely. A ladder 6 meters long leans against a building. The angle formed by the ladder and the ground is 66 degrees. How far is the building from the foot of the ladder? The second question is this. When the sun is 35 degrees above the horizon, how long is the shadow cast by a building 15 meters high? Remember, everyone, that these can be much simpler if you take the time to sketch out a rough idea of the triangle that is formed by the parameters of the question. Do your best to solve these questions, and I will see you in a few minutes.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. If you have learned the tricks of trigonometry, these questions were good practice. We know that the angle formed by the ladder to the ground is 66 degrees. We have also established that the ladder is 6 meters long. Do you remember what function we must use to find the length of the opposite side of a triangle when we know the angle and the length of the hypotenuse? That is correct. We must use the cosine function. Therefore, our problem looks like this. Cosine 66 equals x over 6. A glance at our tables tells us that cosine 66 equals about 0.4067. In order to solve for x, we must multiply each side of the equation by 6. In this way, we find that x equals about 2.44. This is the length in meters from the base of the ladder to the building. Now for the second problem, which we can solve in a similar way. The angle between the sun and the horizon is 35 degrees. The building is 15 meters tall, and we must find the length of the shadow cast by the building. Therefore, we must use the tangent function because that is the ratio of the opposite side of a triangle over the adjacent side. So the problem looks like this. Tangent 35 equals 15 over x. Checking our tables, we find that tangent 35 is about 0.7. Now, we multiply both sides of the equation by x, which means that 0.7x equals 15. Solving for x by dividing each side by 0.7, we find that x equals 21.42. This is the length in meters of the building's shadow. Well done, everyone. That brings us to the end of the lesson. In this unit, we have learned a great deal about trigonometry. We have learned about the functions, the cofunctions, and how to use them to solve real-life problems. It is safe to say you are now masters of the right angle. Until next time, thank you, teacher. Thank you, students.